afternoon, everybody. Welcome to Science Access. Today we'll be teaching on the topic set. Please, if you know that you're new to this channel, please kindly like and press the notification button so that you get notified when there's we post videos regarding sets on other mathematical um, topics. So, and now a set can be defined as a group or a collection of well-defined objects or numbers. That is the definition of set. And they told us that the object may be anything, such as people, set of car, set of houses, set of letter, countries, and towns, etc. Those are what they try to tell us. And a set is usually donated by a capital letter. Note this, that a set is usually donated by a capital letter. Example, capital letter A, B, C, and D. Now, for example, set E, which is our capital letter here, remember a set is always denoted with a capital letter, has elements, even numbers from 1 to 20. From 1 to 20 are the elements of this set. And now what are the even numbers within 1 to 20? And even note that even numbers are numbers that can be divided exactly by 2. Now, with the even number from 1 to 20, it's 2, as you all know, 4, 6, 8, 10, 12, 14, 16, 18, 20. All three can be divided by 2. These are our even number. And now, the next question, or next point here is the element of set. This element we're talking about, what are elements of set? As stated on the board, elements of a set are the objects or numbers that belong to the set. Okay, set E has its own element, right? So the element that belongs to set E are what we're talking about here. Now, for example, and they told us again, element of a set, this element in question are also called member of a set. Either use element or use member. Whenever you see member, that's as we're talking of element. Now, elements are usually denoted by small letter, lowercase letter. I told you, set themselves are denoted by capital letter, the uppercase, where the elements inside of the set are denoted by small letters. Now, note that the elements are separated by commas. As you can see here, element 2 is separated from 4 by comma, right? So elements are separated from each other by comma. So you should have that in mind. And are written inside a pair of curly braces or brackets. So these elements are not just hanging around, they're inside a bracket. So that is what they try to tell us. And describing a set, when describing a set, number one, what you should have in mind is a set may be described by listing all the elements or numbers within the bracket. For example, A, set F. They say that first you describe the element within the bracket. The elements within this bracket, this set, within this bracket are 1, mango. These are the elements. 2, orange, grape, guava, and apple. So first they say we should describe the element. So I have successfully described the element, which are the mango, the orange, the grape, the guava, and the apple. And 2, set M. Using different things, I can use numbers as the total element or numbers. I can use 6, 9, 12, 15, 18. Remember that elements inside a set are separated by commas. Remember that. And note, each number is listed only once, and the order in which the members are listed is in material. What I'm trying to say is that, okay, for example, give us an example. Set 2, 2, 3, 3, 4, 5. Not correct. A particular element cannot repeat itself twice. So they're trying to tell us. So the correct one, instead of this, we write this, which is 2. You should pick out of the 2, we pick 1. Element is not supposed to repeat itself twice or thrice. So 2, 3, 4, 5. This is the right approach, the correct approach. And the same are the same because sets do not contain repeated number. So these are the things you should know before solving or attempting any set question. Number 2 is a set may be described in words A set may be described in words. For example, as circled on the board, M, which is the set, has an element multiples of three. Multiple of three, you see, three, you have six, you have nine, you have 12, and 18. So multiples of three. Now, elements set C, coordinates in English. The pen can be represented by specific flowers, specific things, set of boys, set of girls. They're just things that try to tell us. And the set has domestic animal, our farm animal, our house animal, domestic animal like the dogs, the cat, etc., etc. Three, a set may be described algebraically. A set may be described algebraically. For example, set B equals bracket open. I told you bracket, all the elements are to be arranged inside the bracket. And now x column, right? Minus 10. When x is greater than minus 10 and when x is lesser than or equal to 3, comma, x is an integer. Let me explain the word integer. Integers are positive or negative whole number, including 0. I reiterate, integers are negative or positive whole number, including 0. For instance, let me explain this algebraic expression here. Now, when I said, okay, let me read the note under. This simply means that B is the set of number x such that s is a whole number greater than negative 10 but less than or equal to 3. Okay, let me explain this one now. You say I said B has an element x. This column here signifies such that this one, whenever I see this column, just talking about such that I said B comprises of element x, such that x element is x is greater than negative 10. If the x is greater than negative 10, that means our counting B will be starting from minus 9. So x is greater than negative 10, but lesser than or equal to 3. So it will not be negative 9, negative 8 to 0, so positive 1, positive 2, positive 3. You understand? S is greater than negative 10. If it is greater than negative 10, we should be starting our counting from negative 9 because negative 9 is greater than negative 10 according to the question given to us. And I told you that x is an integer, either positive or negative whole number. Okay, now let's take a look at type of set. Type of set. We have the finite set. The finite set. A finite set is a set in which all the members can be listed. The finite set is a set in which all the members within the bracket can be listed. They are countable. So now, for example, let's say set A has factor of 6. Then set A, these are the factors. Factor 6 says that the number that can go into 6 without remainder. So 1 can go into 6 times, 2 to 6, 3 can go, 6 can go into 6, which is 1. So here, all the members are listed. You see, 1, 2, 3, 4. They are countable. They are finite. So I can count them. So there are 4 altogether. Now, second, 2 infinite sets. Infinite. The first was finite. The second now is infinite. Let's take a look at the definition. And an infinite set is a set in which all the members cannot be listed. They can't be counted. So, for example, now let's just say set B equals the set inside all numbers greater than 5. All numbers inside the brackets of set B are all greater than 5. For example, B 7, 8, 7, 9, 11, 13, 15, etc. etc. So now the note under says that the first few members are listed to show the patterns, and then dots are used to show that the patterns continues indefinitely. Yeah. Okay, that is for the second infinite set. Now, for 3 empty sets or null sets. A set without any member or element is called a null or empty set. The empty set is usually represented by the symbol, the empty, 2 brackets here, like this, or empty, whatever C is, they're talking about empty or null set. So now, note the word empty, null, and void may be used for a set with no element. Yeah, that's what I'm saying. So you, let's say set A equals, that means there's no element. Set A does not have any member, there's no element in it. So now, for example, let's see if B equals the number of people who are 500 years old in Nigeria. Okay, now for example, then B equals empty. No. I think I know there's nobody that can live up to 300 equals to 500. So that is empty because it is impossible. It is empty, it is null. So now nobody lives up to 500 years. So set B is said to be empty because it is impossible. Now the next we're going to treat is the Venn diagram. The Venn diagram is another type of representation of sets. And now a set can be represented by showing its elements in a boundary, usually in a cycle, in a circular manner. Now, for example, let's say set F has the elements of the father, set of father, mother, sons, and daughter. Now, F, family. Instead of you writing it like this, can be represented using the V diagram. Also, now the father, the mother, the son will be in a cycle, in a boundary. So that's why we use the Venn diagram. Now, for example, around two, draw a Venn diagram to show the set. Set A has the number of elements, which is the 2, the 4, the 6, the 8, and the 10. Now, so if you writing like this, I tell you, showcase this in Venn diagram. This, you know that A is our element, is our set, right? Now, all the elements, since you are using Venn diagram, all of them should be in a cycle or in a boundary. So you see the L2 is inside this boundary, the 4 is inside the boundary, the 6, the 8, and the 10. So this is what they're talking about using Venn diagram. Subsets. Set A is a subset of B if and only every member of A is a member of B. A is a subset of B if all the members in A are all in B. Now, for example, let's consider the set. Set C and U. Let's look for the set and the subset. Let's see, T have the element 1, 3, 5, 7, 9, 11, 13, 15. And U have 1, 3, 5, 7. Now, as you can see now, all the elements that are in U, set U, are all already in set T. That is to say that U is a subset of T because the elements in U, they are already in T. So now, all elements in U are also members in T. Therefore, U is a subset of T. This symbol is used when they're dealing with subsets. It's used to represent that one set is a subset of another. See, U is a subset of T because all the elements in set U are in set T. So that makes U a subset of T. This implies that U is a subset of T and T is a superset of U, vice versa. Now, with the diagram, we now they used Venn diagram. Now, the element T has these elements 1, 3, 5, 7, 9, 11, 13, 15. Where set U has elements 1, 3, 5, 7, set T and set U. If you look at these cycles, these sets, you discover that elements that are in U are already in T. That makes, okay, see, they joined the two cycles together. U is inside T. That is to say that U is a subset of T, while T is a superset of U, vice versa. Okay, this is just an introductory class. Our next video, part two, we will be solving more questions starting to this and to the sets. We will solve more on union of sets, the intersection and the rest. So thank you for watching. Please kindly subscribe and like.